Welcome to the 2-Minute Tech. In this 3-part series, we'll discuss the operation and setup of economizers in the Renaissance DDC commercial platform with clear control. In this episode, we'll go over the basics of programming the clear control and economizer controller for free cooling. Understanding how outdoor conditions play into the free cooling operation of an economizer is important. If the wrong enthalpy zone is selected, it could affect the potential savings or cause an uncomfortable environment in the space. Improper selection of the enthalpy zone is the biggest cause of economizer problems. Which zone is needed? To answer that, we have to take a look at the ASHRAE 90.1 standard. The standard divides the United States into 3 humidity categories: Zone A, moist; Zone B, dry; Zone C, marine, and 8 climate and temperature zones 1 through 8. 2 points determine the climate zone. For example, Atlanta, Georgia would be in climate zone 3A, and San Francisco would be in climate zone 3C. Based on the climate zones, the standard requires specific dry bulb temperature cutoff points for economizers. These points are when the economizer stops the free cooling operation. For enthalpy-controlled economizers, the standard states the economizer is to shut down under one of 2 conditions: an outdoor air temperature greater than 75 degrees Fahrenheit or an enthalpy greater than 28 BTUs per pound of dry air. Single enthalpy economizers are controlled by choosing an enthalpy changeover boundary point. In the economizer controller, the enthalpy zone set points are A, B, C, D, and E. Zone A has the highest dry bulb temperature, offering a more aggressive opportunity for free cooling, while Zone E has the lowest dry bulb temperature with the least savings opportunity. Each enthalpy zone sets a boundary line. When the outdoor conditions are to the left of the boundary line, free cooling is available. When it is to the right of the boundary line, free cooling is disabled. When choosing the correct enthalpy zone, we need to look at the outdoor air condition versus the return air condition and the thermostat setting. The enthalpy zone should be set so that free cooling occurs when the outdoor conditions are equal or better than the indoor conditions. In an example, if the thermostat is set to 68 degrees Fahrenheit with a 50% indoor relative humidity, the appropriate zone would be B. This would allow for the maximum free cooling opportunities without the potential of undercooling the space. The A set point could cause overheating of the space by bringing in outdoor air warmer than the thermostat set point. Selecting the right zone is critical to ensure a comfortable space for the occupants and is dependent upon several factors: the building use type, occupancy, and the climate zone where the building is located. To change the setting on the economizer controller with the clear control, open the air filter access and locate the economizer controller. There are 3 potentiometers on the controller. The one on top is the ventilation limit discussed in a previous video. The enthalpy zones are marked with A, B, C, D, and E on the middle potentiometer. And the last potentiometer is the DCV or demand control ventilation set point that we will discuss in another video. Using a small screwdriver, rotate the potentiometer so that the arrow points to the required enthalpy zone letter. At the clear control, go to the economizer menu and use the down arrow to go to the enthalpy zone setting. It should read the new value. Always seek advice from a local mechanical engineer or code enforcement officer regarding the specific requirements for your region. This completes the enthalpy setup of the DDC economizer controller. See the next video on demand control ventilation or DCV. This concludes this episode of the 2-Minute Tech.